Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel, Assistant Professor from LJ Institute of Engineering and Technology. Now in the last session we have seen basic concepts of matrices such as a row echelon form, reduced row echelon form. Then we have seen the rank and rank binormal form, and then at last we have seen the system of non-homogeneous linear equations. Today we are going to start with a topic system of homogeneous linear equations. Now before going we are going to define the system of homogeneous linear equation. A system of m homogeneous linear equation in n variables is a set of m linear equations where m linear homogeneous equations in n variables. Okay, it is given by a11 x1, a12 plus a12 x2 plus a13 x3 plus a1n xn is equal to 0. Same manner, A2 second equation is A21 x1 plus A22 x2 plus A23 x3 up to plus A2n xn is equal to 0. And same manner, AM1 x1, AM2 x2, AM3 x3 and so on, AMN plus xn is equal to 0. Here see, each equation has a equal to 0. That means it is a homogeneous equation. And you have such n equations. That's why this is the system of m homogeneous linear equations. Okay. If you are writing these equations in the form of matrix, then your system is of the form Ax is equal to 0. Now see here equal to has a column 0. So A is nothing but your coefficient matrix. Capital A is equal to A11, A12, A13 up to A1m, 1n. Same manner second row is A21, A22, A23 up to A2n and so on, AM1, AM2, AM3 up to AMN. That means A is M cross N matrix. X, capital X is a vector which is your n cross 1 vectors, or you can say it is a column matrix, okay, with variables x1, x2, x3 up to xn. And 0 is nothing but it is a 0 matrix, 0 column matrix, which is m cross 1. Okay. Now, solution of homogeneous system of equation, correct? So, for m linear equations in n unknown, and if you are starting with a homogeneous system, then there are two possibilities. First one, the system has exactly one solution. That means x1 equal to x2 is equal to x3 is equal to xn is equal to 0. That means each variable is equal to 0. Then we say that it is a trivial solution. But if the system has an infinite solution, then we are going to say that the system has a non-trivial solution. Okay, that means if you have an infinite solution, then we are going to say given system has a non-trivial solution. Okay, please remember that the system of equation has a non-trivial solution if determinant of A is equal to 0. That means if the determinant has a non-zero value, then you have a non-trivial solution. And if it has a non-zero value, then your system has a trivial. Now, if you have any system of M homogeneous system, then it always possesses a solution, correct? That means now if the system is homogeneous, then it is always going to be consistent because it either has a zero solution, that means trivial solution, or it has an infinite solution, that means non-trivial solution. Now, if you are starting with the augmented matrix A slash B, then here B is 0. That means now your augmented matrix is of the form A11, A12, A13 up to A1n and 0. Same manner A21, A23, A24 up to A2n 0 and so on, AM1, AM2, AM3 up to AMN and 0, correct? So if you are writing augmented matrix or you are simply writing the simple matrix capital A, then also the answer is going to be same, because zero column, if you are going to treat any row operation on a zero column, then also the zero remains zero. Okay. Now to solve this system, we are going to apply the elementary row operation on this augmented matrix, and we are going to reduce it to the row echelon form or to the reduced row echelon form. If we are going to reduce this augmented matrix to the reduced row echelon form, then this method is called Gauss Jordan method, Gauss Jordan elimination method. Okay. Now steps to for the Gauss Jordan elimination method. First, what we have to do is write the augmented matrix. Then, secondly, obtain the reduced row echelon form of the augmented matrix by using the elementary row operations. Then, third operation, we are going to write the corresponding linear system of equation for the reduced row echelon form from the reduced row echelon form, and then we are going to solve the corresponding linear system of equation by back substitution method. Now, going with the example, solve the following system by Gauss Jordan method. Okay, so first equation is minus 2x1 plus x2 minus x3 is equal to 0. Second equation is x1 plus 2x2 plus 3x3 is equal to 0. And third equation is 3x1 plus x3 is equal to 0. See, since each equation has a equal to 0, that means the given system is a homogeneous system. And since it is homogeneous, so it always possesses a solution. Either it is zero solution or it is a non-zero solution. That means infinite solution. So first we are starting with the matrix form of a system. That means there is nothing but minus 2, 1, minus 1, 1, 2, 3 and 3, 0, 1 into column of variable x1, x2, x3 and is equal to 0, 0, 0. Okay. So if you are starting with a matrix, then we are starting with the augmented matrix, then A slash B is nothing but minus 2, 1, minus 1, 0, 1, 2, 3, 0 and 3, 0, 1, 0. See, if you are writing an augmented matrix or you are writing a simply matrix say, then also the answer will remain same. Only in a case of if you are writing a simple matrix say, in that case you have to remember that you have to put equation is equal to 0. Okay. Now we are going to reduce this augmented matrix to the reduced row echelon form. Okay, for that first we are reducing it to the row echelon form, and for that operating R12 because we need the first non-zero element 1. So for that we are going to interchange the first row and second row. That will give you the matrix 1, 2, 3, 0, minus 2, 1, minus 1, 0, 3, 0, 1, 0. Now making two entries of below the leading one 0. So for that we are going to use the operation R2 plus 2R1 and R3 minus 3R1. That will give you 1, 2, 3, 0, 0, 5, 5, 0, 0, minus 6, minus 8, 0. And now in a second row, first non-zero element must be 1. That for that we have to divide second row by 5. So dividing second row by 5, so 1 by 5 R2. That will give you the matrix 1, 2, 3, 0, 0, 1, 1, 0, 0, minus 6, minus 8, 0. Okay. And now making entry below the second row 0, second row is leading one 0. So that's why we are going to use the operation R3 plus 6 R2, and that is nothing but 1, 2, 3, 0. That will give you the matrix 1, 2, 3, 0. Second row is 0, 1, 1, 0. Third row is 0, 0, minus 2 and 0. And in the last row we have to make minus 2, 1 because we have to make it leading one. So dividing third row with minus 2, and that will give you minus 1 by 2 R3. So the matrix we will have is 1, 2, 3, 0. Second row is 0, 1, 1, 0. Third row is 0, 0, 1, 0. Now if you are going to write the equations from this one, then this is nothing but this is your row echelon form. But as we have asked the Gauss Jordan method, so we have to reduce this to the reduced row echelon form. So whatever the entries above the leading one, that also must be a 0. So for that we are going to use now row operation R1 minus 3R R3 and R2 minus R3, and that will give you the matrix 1 2 0 0 0 1 0 0 0 0 1 0. Same manner, using the second row, we are going to make second entry of the first row 0. For that, writing the operation R1 minus 2 R2, and that will give you 1 0 0 0 0 1 0 0 0 0 1 0. And if you are going to write down this matrix, then this matrix is in a reduced row echelon form, correct? So this is in a reduced row echelon form. So writing from this is your required reduced row echelon form. So the corresponding system to the given equation, corresponding system is going to be a x is equal to 0, y is equal to 0, and z is equal to 0. Sorry, x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0, because we have given variables x1, x2, x3. So each variable is 0. That means you have a 0 solution, and therefore the system has a trivial solution. Same manner, we are going with another example. Solve the homogeneous system of a linear equations by Gauss Jordan method. First one is minus x1 plus x3 plus 2x4 is equal to 0. Second equation is minus x1 plus x2 minus x4 is equal to 0. Third equation is minus x2 plus x3 plus 3x4 is equal to 0. And fourth equation is x1 minus 2x2 plus x3 plus 4x4 is equal to 0. Again, writing this system in a matrix form, that will give you the 4 by 4 matrix into column matrix x1, x2, x3, x4, and is equal to 0 matrix. And you have the matrix form minus 1, 0, 1, 2. Second row is minus 1, 1, 0, minus 1. Third row is 0, minus 1, 1, 3. Fourth row is 1, minus 2, 1, 4. And into the column matrix x1, x2, x3, x4 is equal to the column matrix 0, 0, 0, 0. Again, writing the augmented matrix, that is nothing but A slash B, that is minus 1, 0, 1, 2, 0, minus 1, 1, 0, minus 1, 0, 0, minus 1, 1, 3, 0, and last row will be 1, minus 2, 1, 4, 0. Now you have to reduce this to the row echelon form, and then you have to reduce it to the reduced row echelon form. So first, to reduce it to row echelon form, we are going to interchange the first and fourth row. That will give you 1, minus 2, 1, 4, 0. Second row is minus 1, 1, 0, minus 1, 0. Third row is 0, minus 1, 1, 3, 0. And fourth row will be minus 1, 0, 1, 2, 0. Now the leading entry below the leading one must, all entries below the leading one must be 0. So using first row, we are going to make the entries of second and fourth row 0. First entry below the leading one. So that will give you the operation R2 plus R1 and R4 plus R1. So that will give you the matrix 1, minus 2, 1, 4, 0. Second row will be 0, minus 1, 1, 3, 0. Third row will be 0, minus 1, 1, 3, 0. And last row will be 0, minus 2, 2, 6, 0. Now, in a second row, first non-zero element must be 1. So for that, we have to multiply second row with minus 1. So multiplying second row with minus 1, and that will give you, the first row will remain as it is, that means 1, minus 2, 1, 4, 0. Second row will be reducing in the form of 0, 1, minus 1, 3, 0. Third row remains as it is 0, minus 1, 1, 3, 0. Fourth row will be 0, minus 2, 2, 6, 0. Okay. And now the leading, all the entries below the leading one must be 0. So using second row, we are going to make the second entry of third and fourth row 0. For that, using the operation R3 plus R2 and R4 plus 2R2, and that will give you the matrix 1, minus 2, 1, 4, 0, 0, 1, minus 1, minus 3, 0, 0, 0, 0, 0, 0. Same manner, the last row is also 0, 0, 0, 0, 0. Now, this is your row echelon form, but for Gauss Jordan, we require the reduced row echelon form. So, the entry above the leading one must be also 0. So, using second row, we are going to make the second entry of first row 0. That means we are going to make minus 2, 0. For that, we are going to use the operation R1 plus 2R2, and that will give you the matrix 1, 0, minus 1, minus 2, 0. Second row is 0, 1, minus 1, minus 3, 0. third row is 0 0 0 0 0, fourth row is also 0 0 0 0 0. Okay, now this is your reduced row echelon form, correct? So from this one we are going, Gauss Jordan method is completed, so we are going to write down the system corresponding to this matrix, and that is nothing but x1 minus x3 minus 2x4 is equal to 0, and x2 minus x3 minus 3x4 is equal to 0. So you only have a two equations and we have a four variables, correct? So basically there are two leading elements, one and x1, first column has a leading one and second column has a leading one. So from two equation we are going to find x1 and x2 in a form of x3 and x4. So you will have x1 is equal to x3 plus 2x4 and x2 is equal to x3 plus 3x4, correct? So two equations we have and four variables are there. So in that case we are going to assume the parameters, or you can put any values of x3 and x4 where the leading elements are not there. Okay, wherever you do not have a leading element, for that variable we are going to assume some parameters, and parameters are nothing but they are any constants. So we are assuming that x3 is equal to k1 and x4 is equal to k2. And if you are going to put these two values in equation of x1 and x2, then you will have x1 is equal to k1 plus 2k2 and x2 is equal to k1 plus 3k2, correct? That means now you have x1, x2, x3 and x4 in a form of k1 and k2. So you can put different values of k1 and k2 and you will get different solutions. So that means here k1, k2 has any value. So this system has an infinite solution, which is called a non-trivial solution. Okay. Now these are the some of the practice examples which you have to do yourself, and if you have any query or any doubt regarding these topics, then please feel free to contact me. Thank you.